Okay, this evening we're going to go ahead and look at solving quadratic equation application problems. This is going to be the worksheet that you're going to get from me tomorrow to work on. So let's read the directions together. Write a quadratic equation for each situation described. Then solve the equation. You may use any of the methods that we have learned: graphing, factoring, quadratic formula, and completing the square. This one, remember, is vertex form, which we did in the warm-up yesterday. Okay? But you must show your work. State your final solution with units. Okay? So let's take a look at number 1. It says the length of a rectangle is 5 centimeters more than the width. The area is 84 centimeters squared. Find the dimensions of the rectangle. So when you're doing a problem, personally I'm visual, so I would draw a picture. We have a rectangle here. And it says that the length, okay, that would be your longer side, is 5 centimeters more than the width. So they describe the length in terms of the width. They describe the length in terms of the width. But they don't tell you anything about the width here. So W is going to represent my width, and my length, again, is being described in terms of my width. So that's how I want to write my length, not with an L, but with a W. It says 5 centimeters more than the width. So we're going to add 5 to the width. Does that make sense? So here's your length. It says it's 5 centimeters more than the width. So, for example, if the width was 1, then the length would be 5 more than 1. So it would be 6. Alright? Now, it tells us that the area is 84 square centimeters. So the area is 84. So the formula for finding area of a rectangle is length times width. So we're going to multiply the length times the width. And that's going to be equal to the area, which in this case is 84 centimeters. And then we want to solve this equation here for W using one of the methods that we've already learned about. So as you all know, when you solve, you want to set the equation equal to 0. So I'm going to go ahead and simplify the left side by distributing. Then I'm going to go ahead and subtract the 84 to get my 0. On the right. And now we want to solve this. Well, we've used the quadratic formula, which would work here. We've done the vertex method. We did that in the warm-up yesterday. So let's just review factoring, in case we've forgotten. So A times C, so 1 times negative 84, B value on the bottom. So I want two numbers that multiply to give me negative 84, and they have to add up to give me 5. So factors of negative 84. So I calculated all the factors of negative 84 and I came up with 12 and negative 7. They multiply to give me my top number and they add to give me my bottom number. Putting my a value on top, which in this case is 1. So I have two factors here. We have 1w plus 12, and the variable is w instead of x, 1w minus 7. And then solving for w, set each factor equal to 0. So we have w plus 12 equals 0, and w minus 7 equals 0. Then we're solving for w. In this case, we're going to get w equals negative 12. And here we have w equals 7. So remember, this is a real-world application problem. So remember that w represents the width of a rectangle. So one of these answers is not going to work for us. Right, the negative number. Can't have a negative width. This is known as, since it is a solution, but it's not a solution that works, it's called an extraneous solution. An extra solution, but we don't need it. But we found a width that does work right here, a width of 7. So it says find the dimensions of the rectangle. So we know our width is 7. Don't forget your units, so it's in centimeters. And then the length is going to be 5 more than 7, so that would be 12. So 7 centimeters by 12 centimeters. And there's your answer. Let's take a look at number 2. I'm going to try to help get some of these set up for you. So it says we have a square banner, had 4 feet added to its width, and 2 feet subtracted from its height. The banner then had an area of 91 square feet. How long was the side of the original square banner? So we have a square. Now, as we know, the sides of a square are the same. And I'm going to go ahead, instead of using length and width, because these are going to be actually the same, I'm going to use x and x to represent my two sides. Okay. Now it says 4 feet was added to its width. So I'm going to add 4 to the width. And it says 2 feet were subtracted from its height. Well, I guess I should have added the 4 down here then. And subtract 2 from the height, although it's really not going to matter. It says the banner then, very important word here, had an area of 91 square feet. How long was the side of the original square? So again, we're given the area, so the formula is length times width. So x minus 2 times x plus 4. And that's going to be equal to our area of 91. And we want to go ahead and solve this for x using whatever method you want to use. And then it says how long was the side of the original square banner. So we would not have to plug this in because this would be the new banner. The original banner was x by x. So how long was the side of the original square banner? Well, it's going to be whatever x equals once you solve this equation. Okie dokie. Well, tomorrow I think I'm going to have you guys working, definitely working with your partner, possibly working in teams. We'll see how it goes, and we'll continue working on these problems in class tomorrow. Hope you're having a good night.